u is equals to 1 plus root 3I and v equals to 1 plus I. And we know this I is an imaginary number and the value of I is square root of -1. That is the reason we have I square as -1. So for A part 1, all we have to do is we need to show that u over v is this. So if I talk about u over v, so that's going to be my u over v has to be equals to 1 plus root 3I over 1 plus I. And if I want to get it in this format, I have to do it like a rationalization. So which means I have to multiply and divide with the opposite or the conjugation of the denominator. So that's going to be, I have to multiply and divide with 1 minus I. So if I do that, so my numerator has to be, so if I multiply this 1 to these things, so that's going to be 1 minus I, and root 3I times 1 would be positive root 3I. Then positive root 3I minus I is going to be negative root 3I square. And in the denominator, so 1 plus I times 1 minus I will be, so using the identity of a plus b times a minus b, that's going to be a square minus b square. So keeping that identity in mind, so this is going to be 1 square minus I square. And we know this value of I square is going to be -1. So if you replace this one, so this will become positive root 3. So 1 minus, and here if I take I common out, so it's going to be plus -1 plus root 3 times I. Only taking I common out for these two things. And here if I simplify this one, so I square is -1, so negative root 3 times -1 would be positive square root of 3. And entire thing divided by 1 square is 1 and I square is -1. So it's going to be 1 minus of -1 will be 1 plus 1, which would be 2. So now this thing can also be written as, if I write the real parts together, so that's going to be 1 plus root 3. And if I just shuffle these things around, so it's going to be root 3 minus 1 I, and entire thing divided by 2. So this thing can also be written as 1 plus root 3 over 2 plus root 3 minus 1 over 2I. And this is what we need to show it for part A. Now, by expressing both u for part 2, by expressing both u and v in the modulus argument form, show that u over v is this. So in order to do that, so first of all, we need to express this both u and v in the modulus argument form. So the modulus argument form would look something like r into cos theta plus I sin theta. So we need to figure out what is the value of r and what is the value of cos theta. This is what the modulus argument form would look like. So my u would be 1 plus root 3I. So in that case, the formula to calculate the r would be square root of, it's going to be a square plus b square. So whenever I have any complex number, it's in the form of a plus bi. So it's going to be square root of a square plus b square. So in place of a, we have 1, and in place of b, we have root 3. So it's going to be 1 square plus root 3 whole square. So this is going to be square root of 1 plus root 3 whole square is just 3. So which is nothing but square root of 4, which is 2. So in that case, for u, the modulus is 2. If I talk about argument, which is theta, so theta would be equals to tan inverse of b over a. So which is nothing but in this case, b is root 3. And in place of a, we have 1. So tan inverse of root 3 is going to be just pi by 3. So now, whenever we talk about solving for theta, we will always get two possible answers whenever we do it with the tan inverse. One answer would be pi by 3, and the other answer has to be 180 plus theta. So which is nothing but pi plus pi by 3. If I say pi plus pi by 3, so that's going to be equals to 5 pi by 3. So which would lie in the third quadrant. So now, out of these two, which one is the right answer? So we can figure out that by looking at in which quadrant that this point would lie. So this point would clearly lie in the first quadrant because both the real part and the imaginary part both are positive, and in the first quadrant the angle has to be pi by 3. So that is the reason u can be written as in the modulus argument form. It's going to be 2 times cos pi by 3 plus I sine pi by 3. So similarly, we have to do the same thing for v. So now we have v to be 1 plus I. So in place of a, we have 1. In place of b also, we have 1. So in that case, so my r value would be square root of a square plus b square, which is nothing but 1 square plus 1 square, which is nothing but square root of 2. And theta has to be tan inverse of 1 by 1, which is nothing but tan inverse of 1 is pi by 4. And again here there will be two possible answers. One is going to be pi by 4 and another possible answer would be pi plus pi by 4, which is nothing but 5 pi by 4. So now out of these two answers, if I look at this coordinates, so 1 plus I, so that is going to lie in the first quadrant. So that's why it has to be pi by 4 itself. So now if I talk about u over v, so in that case, my v has to be equals to root 2 cos pi by 4 plus I sine pi by 4. So in that case, u over v has to be equals to 2 times this cos pi by 3 plus I sine pi by 3. We can also write it as cis pi by 3. So that's another way of writing it. So it's going to be cis pi by 3, then divided by v is nothing but root 2 into cis pi by 4. Now, we have some law, something like this. Whenever we have cis of theta 1 over cis of theta 2, this is going to be equals to cis of theta 1 minus theta 2. So keeping that in mind, so first of all, if I simplify this one, root 2 will get cancelled out here. It would be just root 2 in the numerator, root 2 times, and this can be written as cis of pi by 3 minus pi by 4. So which is nothing but pi by 12. So root 2 cis pi by 12, we can also write it as square root of 2 into cos pi by 12 minus I sine pi by 12. And that is what we need to show it for part 2. And that is the right answer for part 2. Now, finally, if I talk about part 3, we need to figure out the exact value of pi by 12. So now, in order to do this, we have to consider taking these two things. Now, both these uv are same. So that's why what we could do is, if I write that, so u over v is going to be equals to, for part 3. So it's going to be root 3 plus 1 over 2 plus root 3 minus 1 over 2i. And this is also equals to, this is going to be root 2 into cos pi by 12 plus root 2 into sine pi by 12 times I. So now if I equate both the sides, the real parts and the imaginary parts. So by equating the real parts on both the sides, real parts has to be square root of 3 plus 1 over 2 is equals to square root of 2 into cos pi by 12. So in that case, so cos pi by 12 would be equals to square root of 3 plus 1 over 2 into root 2. Let us call this as equation 1. And similarly, if I equate the imaginary parts, on both the sides. So this is going to be square root of 3 minus 1 over 2. Whenever we are equating the imaginary parts, we should never ever think about writing I. So it's going to be square root of 2 into sine of pi by 12. So in this case, if I make sine of pi by 12, so sine of pi by 12 is going to be equals to root 3 minus 1 over 2 into root 2. So let us call this as equation 2. So in that case, if I need to find out what is tan of pi by 12, so tan of pi by 12 would be same as sine pi by 12 over cos pi by 12. So that is the reason. So from equation 1 and 2, so sine pi by 12 is nothing but root 3 minus 1 over 2 root 2, and cos pi by 12 is nothing but root 3 plus 1 over 2 root 2. And here 2 root 2 and 2 root 2 can get cancelled out. So I'll be just left with root 3 minus 1 over root 3 plus 1. But we should not leave our final answer to this part, because we want the final answer is in the form of a plus b into root 3. In order to do that, so we have to kind of rationalize this, which means we have to multiply with the the conjugation of the denominator. So that's going to be square root of 3 minus 1 over square root of 3 minus 1. So in the numerator, it is just going to be when I expand it. So square root of 3 times square root of 3 would be just 3. Then square root of 3 times minus 1 would be minus square root of 3. Then minus 1 times this 1 would be again minus square root of 3. And finally, I'll have it as positive 1. And the entire thing divided by the denominator is going to be a plus b times a minus b. That's going to be a square minus b square. So it's going to be root 3 whole square minus 1 square. So in that case, 3 plus 1 is going to be 4 minus, it's going to be 2 root 3. And the entire thing divided by 3 square is 3. So 3 minus 1 would be 2. And I can take 2 common out and I can cancel out with the denominator. So that's going to give us the final answer to be 2 minus root 3. And this is the final answer. So when I compare it with it, so we can clearly see the value of A is 2 and the value of B is negative 1. And this is the right answer for this part 3.